In this lesson, I'm going to have a look at how we generally apply inverse trig functions. So I'm going to look at sine, cosine, and tan, just so you can see how it's applied, and you can link it to processes you've already learned. So let's consider y is equal to cos x, where y is known, and we're trying to identify the value of x being an unknown angle. When we have a look at this, so obviously we'll start with cosine. So as we're trying to solve for the values of x, then we'll have to inverse this relationship. So if we're saying x is equal to arc cos of y, that should make sense about what we're trying to do. And obviously y in this scenario is that given original cosine value. So in a unit circle, the cosine values represent x in here. So it could be that any point along here is our unknown. So let's have a look at these two scenarios. There's two solutions that you should be able to see. So when it says positive value, we have a solution that will represent this angle, and another solution will be this negative angle. And so we should be able to see here that we've got two solutions. Our first angle will be just that positive acute angle plus any coterminal rotation. So we can say that k is an element of a set of integers. Now the other solution is that we've got negative of that acute angle plus any coterminal solution. So we can see here that for a cosine scenario, where we're looking at those x values, the solution can either be that positive angle or negative angle, and then any of the coterminal solutions. So we have infinite solutions here. If we look at the other side, and we're looking at where we intersect to get this solution, again we've got an angle here, which will be pi, subtract the angle, and we've got another angle here, which can be pi plus the angle. And so therefore in this scenario where we started off with a negative value, we end up with our solutions being the first one. We have pi subtract that acute angle plus 2 pi k, and pi plus that acute angle plus 2 pi k. So hopefully that makes sense, that when we're looking at that inverse trig, we're looking for those unknown angles, and depending on the given domain, they may be infinite or a defined set of solutions based on how many rotations we have to go through. When we look at sine functions, and so we'll start with y is equal to sine x, where again this is known and this is unknown, and we're trying to solve for that. Now keep in mind that this y value will be in the y-axis this time, and so when we look at the inverse, then we've got x is sine to the negative 1 of y. In that unit circle, then we can look at again a positive and a negative solution. So here's our positive solution and here's our negative solution. And for the positive, here's our 2 points of intersection. And so we've got our angle, and then we've got pi subtract the angle. And so for the positive side of the solution, we've got our first angle. We've got theta plus 2 pi k. And for our second one, we've got pi subtract theta plus 2 pi k. again where k is an element of a set of integers. And if we look at the negative side, so if it was a negative value that we're looking to solve for, we've got our two intersection points and we've got our two acute angles. And so our first one would be pi plus that angle plus 2 pi k. And our second one would be 2 pi subtract the angle plus 2 pi k, again, where k is an element of a set of integers. So that inverse trig function allows us to solve for those, and we've got our infinite solutions depending on the given domain. Finally, when we look at tan, and we've got y is equal to tan x, and the inverse is x is equal to arctan of y. When we look at this scenario, it's a little bit different, but still similar. If it's positive, then we're looking at the x and y values being the same. So that means we're going to end up in this one where we've got a positive over a positive, or this section where we've got a negative over a negative. Okay, so we're looking at our angle just being theta, or our angle being pi plus theta. And if we're looking at the negatives, then it means either the x or the y are negative and the other is positive. So we end up in these two quadrants. So negative, they have an opposite sign. Okay, so we end up with our solutions for the positive. Our first one being theta plus 2 pi k for all the coterminal solutions as well. Theta 2 being pi plus theta plus 2 pi k, where k is an element of a set of integers. And we look at our negative, theta 1 being pi take theta plus 2 pi k, and our second one being 2 pi take theta, or just negative theta if you prefer, plus 2 pi k, again where k is an element of a set of integers. So essentially that's how we use these inverse trig functions to solve for unknown angles. It is really dependent on the domain given and the scenario, but that's what we're doing. Now you should have used a similar process earlier in methods and in specialist in Unit 2, where you would have gone through and practiced these techniques. Okay, hopefully that helps clarify. The next lesson will be on the derivatives of inverse trig functions.